Hello everyone, welcome to another stream. How are we doing? So, for the past two streams we've been working on these render changes, and we've built this sort of material caching system where we can hold up to about 1,000 unique materials, and we're getting those uploaded to GPU memory as well. We currently got some hard-coded texture data that's being loaded in, and then we've also got different LODs. So right now we're only loading it the lowest level of detail, but hopefully by the end of all these changes, we'll be able to stream in the higher resolution, the higher levels of detail. So we're also going over the models and getting those. I think this comment's old, but we're going over the model instances, getting the material palette, and if not, getting the default material palette for the model and loading all the materials that are associated with that, and then uploading those, and only letting the model instance render if the material palette is fully loaded and ready to go. We also loop over the material cache and upload the material palettes and the materials themselves. Yep. So the only thing that's left to do CPU side is to read back some LOD feedback, but we need to actually get the rendering working. So we're in a place where we can get the rendering working. So we're gonna go ahead and get started with that today and hopefully get something on screen, which would be nice. So if we go to graphics.c, we have graphics internal. We'll go to the material cache. So the material cache for each LOD has a LOD cache, and each LOD has a 2D texture array. So these have a bunch of slots basically. So for the lowest LED, there's 1,024 slots, and then on the next LED, it shifts right by 4 or something like that. So there'll be 256, and so on, until you get to about 1. So we have a way to sort of like sub-allocate with just this bit set here. So whenever we have a material, it's stored in one of these LOD caches, basically, for each one of these texture 2D arrays. So, now we need a way to get these resource IDs to be accessible on GPU. So in my shader compiler, I can basically cast an index, so whatever index I want, let's say 55, into a resource. And behind the scenes, that just basically looks into an array of descriptors and fishes out the descriptor for the buffer and gets you that, right? So this is very powerful because what it means we can do is we can have our textures are created in an order, which means all we need to do is know where the first one is, and then we can know where the rest of them are. So what we're probably going to do in this material cache is to keep note of the first resource index. Now the problem I've got with this is we load them from the back, and we do this because it's the way I calculate the number of array layers. But I might go the other way around. Let's say we start at 1024. Yeah, let's not do the reverse loop anymore. So let's start from 1024, and now we're gonna shift right by 2. Yeah, so it gets like powers of 4 basically. Is that still the same thing? And you want to max 1. I think that's right. So we did 1024. 2, shift right 2, shift right 2. Right, that works out. Yeah, good. So the high resolution ones will just end up with like 1, maybe. We'll see. Yeah, we'll live with that. So this means it will allocate them in order now. So whenever we call texture initialize, it's going to bump allocate in a resource index. So what we can do is we can get the base here. I want to jot down what the resource index, the sort of base resource ID or index for, I guess we can get that after. We can say after you've done all those, go into the first LOD cache. So you go right, so you go cache, LODs, first one, then albedo, and then we'll get the resource index for that. So we GPU resource index. And now all we have to do is get this to the GPU, and then get this resource index to the GPU, and then we can just calculate stuff automatically. So if we go to graphics, internal shared, I've got to reduce all these files. It's way too many files. My brain is like, where is that thing declared? Okay, so graphics globals. This is the section uploaded from CPU. And then from here, it's just persistent GPU stuff. I should probably put a comment there. GPU only data. So this is just like a global buffer where the first part of it is the CPU can send that. And then the GPU can obviously change this and read and write to it. But then this is the data that the GPU can only read and write to. We don't upload past this point. So this stays persistent basically. So this stays persistent between frames. GPU only data and is persistent. Okay. So all we're looking at doing is adding another thing. So this would be the material cache base res index, and then so we just got to populate that CPU side. So we'll find where that is declared. So all we have to do is just, we could probably know this statically maybe as well, but I don't know. We'll just pass it up, right? Start being cached. So material cache base res index. Now the magic is, right, we can now go ahead and get any of the textures. So all we have to do, any of these LOD texture arrays. So we're going to make like a function for each of these, and it's going to take in a parameter basically saying like what LOD do you want, and then you'll get back the correct texture based on the LOD. So it'll just be a bit of maths, right? So we go to graphics, internal shared. Is there a material section here? Well, this is the old material stuff, isn't it? There's not one yet. It's okay. So we'll add a new material section and we'll get rid of this old one. This is when we used to have hard-coded values for the whole sphere, but now we're getting it from a texture. So we'll call it material. Now what we have to do is make a function like, hang on a minute, the globals, alright, hang on a minute. So we need to get a read-only texture 2D array. Now, do you want a read-only or do you want a sampler? Like, because you're not just getting a, you don't like fetch a pixel, right, or load a pixel. Well, you want us to sample always at this point. So I think we just want the sample texture, right? And then we'll get back something like that. And this will just be a function called something like graphics material so graphics material cache albedo, you pass in the LOD of the, so when we upload a material from the when we upload a material, we upload this sort of packed material. It's got an LOD and it's got a layer index. So the LOD will get you the array, and then you've got a layer index that you can use to sample from that. So what we have to do is do that graphics global. Graphics global. Got to be careful about the synchronization code as well, actually. So this will be what am I doing an address for? So we want to get the property. It was material cache. I forgot what it was now. That one. Yep. So now we have to do a bit of maths here, right? So how many textures are there per LOD? Graphics, material, LOD, textures, count. I think there's 5 or 6. I think it's maybe 6. So it'll be plus LOD multiplied by graphics, material, LOD, textures, count. Right, and that's all we have to do. It should be quite nice. Just got to go back into the internal header and look at the 0. Yes, there's 3 there, and then another 3, so that's 6 overall. And yeah, here's the actual ones in the LOD cache. Right, so albedo's first, then emissive, then right. So what we could do is say we could actually just make a nice enum. And then you just say basically graphics, material, texture. Now I've already got something called that. So this is like a texture. I don't know what it would be called. So it's like a, so you've got the albedo texture, you've got the, emissive texture. It's just something like that. It's like a texture. You could call it texture index. Yeah, let's call it texture index for now. If anyone's got any nicer names, let me know, and I'll happily accept any better names than this. But this will just allow us just to get going. So this way we can say texture index count, and that's what we can use for the, instead of this one now. So be albedo. I think I remember the order. Emissive strength, metalness, roughness, height, and normal. So that's the order we got them in. So now what we can do is multiply by this stride in a sense, like that. And then you just add that onto there, like so. And then all we have to do is copy paste that a few times. And now we can just do the rest of them, right? So the next one is just look for albedo. So emissive strength. Oh, metalness, roughness. Height and normal. So that was emissive. Then height and normal. Right, so that looks like it'll work. We've got to be careful about the synchronization code, but now from shaders. Oh, okay, we've got to be careful with this. That's a color scalar. So it's just a 0 to 1 value. Sorry, no, or 0 to whatever number really. Metalness roughness 0 to 1, but there's 2 of them. And then height is another probably 0 to 1 value. I'm not sure about that yet. Normal is probably a 3. What did I do for that in the end? Oh no. This is a special compressed into 2. Just got to adjust these as well. That's a 2. So that'd be in an octal, what was it called? Octahedral format, which we'll see more about that in a little bit and what that is. Because we're using the octahedral format for actually albedo and emissive, like sampling these in general. So we'll see exactly what that means in a bit. So the thing is, what to be careful about the synchronization code you see. So the problem is I don't want to like sync on all of, so from the CPU side we do an upload, and that's going to put a barrier in to sort of transition it into doing an upload basically, right? And then we need to do some cache flushes after that. So I think we can make a dummy dispatch to do those transitions, and that might be good enough. So then they use for read only after that. So after they've been uploaded to, we can just do a, yeah, that will do it, I think. Wait, did I upload to the actual textures? I think I did. Let's go back to it. So it's like cache update. I very rarely like to call functions update, but it does so much that it deserves being called update. Right, so go over all the materials, and yeah, we are copying. Right, so those are going to put in barriers probably. They're probably not that efficient, but it's copying currently from a temporary generated texture that we've made into here, but later on we'll read from an asset file and stream it up. Well, this is not really, it can be classed as streaming, but it's not async, and eventually it'll be async. So done in the background off the main thread, or off the render thread, but not for a while. So right now it's just copying from some pre-generated material texture procedurally that's just living in GPU memory, and we're copying it to this lovely material cache where it's just got a bunch of pre-allocated slots available, so we're not dynamically allocating memory at all. We just load the file in and copy it to the GPU when we need it, and we shuffle things around and all that, right? Yeah, I've got to do the shuffling in that at some point. We'll see about that. We might do that soon. So from here, when we do this sort of texture copy, it's going to do this sync code, and I've got to do this because the editor's not smart enough to figure it out. Right, so in here we do this sort of sync, so we say, hey, it's write only, and we're doing this copy. So we've told Vulkan that, but now we need to tell it that it's going to be accessed from a compute shader after we've done the copies, right? So we probably want to say, right, keep note of all of the LOD caches that got changed, and then run a dummy compute shader launch, which will just put a barrier down. Oh wait, I think I can put a barrier down anyway. I've got a thing for that, but that would be good actually. We can have that. So what I want to be able to do is get an array of, so we've got a fixed number of these, right? So we just go, well, maybe not. All we need is a bit set. LOD cache is changed. Yeah. So start off as 0. All we do is go, all right, well, we're changing this one here. So we go, okay, or equal 1 shift left LOD. Like that. Don't think you need that. So now we just need to do a loop over all the bits, which is really easy to do. So at the end, we just do a while loop and say while we've got bits. I really love looping over bits, it's great. So at the end you just say, so I've got a function called bit remove least set bit. I think I need 32 one to be honest. Or caches. So what it does is do take 1 and then AND that with itself. So like that. And that removes the least set bit. Then all you need to do is just use there's some instructions to do, basically get you a least significant bit index. So that's our LOD in this case, because each bit represents an LOD. So we're finding the bit which is set. So I've called that, I've got a maths library, so it's bit least significant bit U32. LOD cache is changed bit set. Okay. So all this does on Windows at least. No, sorry, Linux at least. It does the count trailing zeros. And then leading zeros is the other one. Then on Windows, you've got to do the bit scan forward. And that translates to this count trailing zeros instruction on x86 and ARM. They've got similar ones. So, pretty good. Now, in here, we just want to basically go, okay, do a synchronize that we want to read on those LOD caches, LOD cache textures, and then we'll insert a pipeline barrier basically and do all the transitioning. So be ready for whenever we use it later on in some other stage. Some other compute shader dispatch like the rendering ones. So I don't have to just sync on all of it later on. So if we just find, yeah, I'm trying to just find that line so I can copy paste it. But yes, we get the LOD cache, then we do LOD cache, albedo. Alright, just copy those 6 times. Right, albedo, emissive strength, metalness, roughness, height, and normal. I think that was it. That's 6, right? Yeah, it is good. So after that, we've basically said, hey, so we're going over all those different log caches which got uploaded this frame. Sync, 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 sync. But we've not issued a command yet. We could though just say, so I could insert a dummy command and then it will sync on those, but this could, all right, how about, yeah, but this will just, I think this is fine. So on the next dispatch, it's just going to sync on all of these guys anyway. Yeah, I think that'll work out. But it's got to be an actual dispatch. Yeah, okay, we're going to insert a dummy. Maybe. Let's go to GPU Vulkan for a sec. So where's that pipeline? Yeah, this copy. Right, so from the mode, if you got the clear bit or the copy bit, it will put those stages. If not, it'll do compute shader. Right. So I think I would like to be able to say right, so that's the access modes that you do when you do a sync. Oh, okay. Yeah, so we can just do a dummy one. So we could just be like, let's add another one called like barrier. Right, and it just is a way for you to manually place down a barrier. It's not that great. You shouldn't really use this much. Let's go and get that in there. That'd be a bit of fun. So yeah, we'll just say you just call this sort of barrier thing. I wonder if command prepare resource barrier. If you got any resources, then all right. Yeah, I wonder could we. Yeah, so the problem is it's gonna do all the sort of texture viewer, isn't it? It's gonna it's gonna say that it's written to there, but it's not. So I might call this explicit barrier. That might be a better name. Because barriers are kind of implicit. That would be better. So I'm thinking like, right, well, I think we just manually need to just do that basically. So the finalize would do is the texture cache stuff and, sorry, texture viewer stuff. Yeah, I think we're fine. So we'll put comments, I remember this, right? So useful when you want to sort of useful when you want to no, let me put this a whole separate thing for itself, right? So must, you know, all right, let's put an assert in here. Well, now keep it like that. Right. So useful when you want to sort of sync, pre-sync a bunch of resources beforehand. Right. Must use GPU command sync resource star before calling this function. And then we can say like an example is that we have uploaded. So we can just say a group of textures have been uploaded to from the CPU and now have been and will now be used as read only on GPU, read only in compute shaders from now on. Rather than syncing them for every shader they are used in, instead just sync them all once, then instead after the upload just sync them all once and call this explicit barrier. And that would be proper ideal. Hey Supersonic, this is Falling Asleep Music. I see you're using Helix. Has it been working out for you so far? Well, do you want some more upbeat? It's just pretty chill, you know? That's where you need to be. Chilled out. Just let the ideas flow, you know? So like... Helix. Yeah, it's good. They've actually improved some of the things I've been... little nitpicks I've had. Like they used to have a thing where it's like, when you pressed enter, it never used to put like the comments down here. But now it does. It carries on comments, which is really cool. So Helix, I'd say it's really great in terms of like if you want to come to a modal editor and you're looking at NeoVim, you're like, what the crap is this config file? The config file for the config file for Helix is like just a config file. It's not like a whole new programming language that you have to learn. And I've obviously changed a whole bunch of key commands because I'm using the Colmac keyboard layout, and that's just a problem with terminal-based programs is it doesn't use scan codes, it always use key chars, basically, or you know. And it's great in terms of like it comes built in with like lots of stuff like the language server protocol. If you're a fan of that, I'm not that much of a fan of it, but it comes built with that. It's got like this sort of like thing like telescope that TJ made for NeoVim, but it's in here now. So you can search through files, like grep through them and stuff like that. It's even got you can press space and question mark to get a command palette. So any command that you want, providing you get either search for the description or the command name, and you can figure out like, hey, how do I join selections? Or how do I think there's a way to sort of like there's a way to like reduce you basically just search through this and find like every command. I think there's nearly 400 of them, or you can just scan through it and just see which ones you might want to it gives you the keyboard commands for them, or you can go ahead and rebind it and it gives you the updated rebinds as well. So it's nice and user-friendly comparison to NeoVim, I would say. But yeah, I switched to it from NeoVim because I updated my config and then I updated my NeoVim and then my config got busted. Or some plugins and my config got busted. So I just couldn't be bothered to fix it up. So I'm just using basically a vanilla Helix and it's good. I would say my next complaint is that it really relies on the language server protocol, and I would wish that it doesn't rely on the language server protocol that much, and just do dumb, stupid text string cataloging, if you want to call it that, because that's what I do. Is I have unique function names and structure names, and that's all you need when you do C programming. Not some language server protocol, which is a bit flaky. Have I tried Z? Yeah, I tried out Z for a bit. It's a bit of a GUI one though. And I know it comes with like a Vim mode, but Vim modes are never that great really, because the whole editor isn't built to be a modal editor. But I did like the look of it. It was a bit early when I looked at it though, but you know, it's probably better than Visual Studio Code. Have you been using a Z there, an artist? Right, so I think we're ready now to get into the shader and do some sampling. So in the shaders file, we've got a function called calc surface color. This does the shading. So whenever we want to do shading, we'll get our material, throw it in there, which we might. Oh, that's interesting. Yeah, we'll be getting a material index now, isn't it? Yeah, I think we'll be passing a material index from now on. Should be proper cool. And then we fill in this shading structure. So we go like, hey, where's the vector towards the camera? Where's the hip position? And what's the surface normal? And with this information, we can do all the shading we want. And it just holds other parameters that is used throughout the whole calculate surface color functions. Basically, there's a bunch of little sub-functions it calls, and it passes extra things around. So it just pre-caches it in the strut and passes that around. It's all inlined anyway, it's shader code. So it does all the PBR lighting and stuff and returns to your a color. So in here we used to pass in a hard-coded material, like albedo, emissive, roughness, and metalness. And that'll be the same thing for the whole ellipsoid. But now we're going to be sampling into a texture so it can change over the surface of the ellipsoid. So it's going to be powerful. Now, I've been using Vim for a long time now, but it's starting to really annoy me that I have to use plugins and they're all in a scripting language. Right, ironically, thinking of making my own editor at this point, but Z could have been a possible solution. Well, yeah, just give it a go, right? I know I've fantasized about the idea of building my own editor and stuff, but it always boils down to like it takes me away from doing actual projects and stuff. I'm saying actual projects like a text editor isn't an actual project, but you know, game projects I want to work on. Which is more of a thing I would like to achieve rather than making a text editor. But I think the people who want to build text editors and give me choice, I think that's really cool. But yeah, like Helix is pretty decent. If you like all the sort of like NeoVim stuff that's going on, but you don't like all the Lua that's going on, right? Helix is a good place to go to. But yeah, my one gripe is just that LSP. I want something more basic and simple, something dumb. But Z, give it a go. I thought it was a nice feeling editor. If you like the sort of UI type, GUI type of text editor, it seems quite nice. But yeah, it didn't seem too heavyweight, basically, at the moment. But yeah, we'll see how it ends up. It's got lots of marketing saying it's like a fast editor, but we'll see what it's like. I've been thinking that for the first time. Sorry, I think I have had the first breakdown in a while trying to get text editor just running. NeoVim is really annoying with all the plugins. I don't like the Vim model. I love Cocoon, but at the same time I hate it. Could write a book. And Helix just lacks a very specific configuration I need. I hate all the LSP and diagnostic stuff I can't turn off without configuring every single language, and I personally use to split up the Windows split implementation kind of right. I see. Yeah, I know, right? I think you're the type of person who needs to build their own text editor. See, that's the thing, right? You know, if things really annoy you that much and you just can't get on, then maybe just build your own text editor and just make it for you, and just, you know, only support ASCII or whatever. You know what I mean? Just do the things that you need. If you don't need UTF-8, don't do it. And just, you know, you might not even need. You probably need some form of configuration, but it could just be very basic because it could just be for you. And then yeah, it would be a lot easier to make rather than trying to make one which everyone else can use. Mm-hmm. Yeah. Yeah. I just got used to the way Helix works. It seems pretty alright. I like the F key thing. Oh no, I've put it on my F key. But yeah, I press the F key, and then it just highlights every word that's 2 characters or more, and it allows me to jump to it by just pressing the 2 characters, and then I can go there. That's a really great. So that's why I got rid of the relative line numbers, because I can just do this now. It's quite ideal. Right. You make it programmable in C. Yeah. Yeah, the F mode is GW. Yeah, but GW is like just too long-winded. It's like also it's a bit of a stretch as well. It's RSI inducing. So if you put it down to 1 key, then in 3 keys you can be anywhere on the screen, which is very powerful. It's better than 4 keys. But yeah, configurable. Yeah, make it all configurable in C or something. Yeah, maybe. Yeah, like I don't know, but the problem is like when you try and give a text editor to someone who's a programmer, like chances are they don't know C, right? So they're like, oh yeah, we've got to make it accessible in like Lua or whatever, right? And then before you know it, you get some big old Lua script, or worse, Python. You know, Python. But yeah, I think. Well, who was it? Was it Ray? You know Ray. He made Ray's done his own like Raylib guy. Raylib Ray has done like his little text editor, didn't he? I think Raylib. I think. Has he actually released it? Raylib Ray. Maybe is not. But it was basically like a little text editor that you can like configure and just, you know, then modify it like a base text editor. But I don't know. Maybe I can't find. Maybe it doesn't exist yet. Or maybe I was dreaming. Okay. So we need to pass in the material, the new GP material, graphics material packed maybe, but then like Your materials are only going to come from a material. You can only have 1,000 materials. So I think you're passing a material index. So what you can do is get your, excuse me. So I think we can pull out the material packed from here. So that would be like a, now I don't have the buffer available, but I think we can get it from, if we just store it. As a material of that in the globals. We've got to put the pallets in there as well, actually, probably. No, we don't. Right, so from here, we've got, we can now get the LOD and the layer index. So I think in the shading, it might be useful to store, I don't know, where are these things used? There's meltness, roughness, albedo. Where's the other one? It's calculate light, isn't it? Like radiance. Does that use any of the, right, it uses roughness and albedo. Oh, so this is material strut. Right, so maybe what we can do is we can keep the material structure, but have it stored, yeah, cache the results. So we'll call it here material. So all we'll do is we'll like pre-sample it all, I think. I think so. That makes the most sense. So we'll so do like shading dot mount or albedo, so that'll be sample texture 2D array. Now the texture is going to be based on graphics material cache albedo. I think it was called. That was a thing, right? Yeah, then you pass in the LODs. The LOD will be material. Right, you gotta get the LOD. So that'll be graphics material packed LOD. That's right, wasn't it? Yeah, material. Then you want the layer index was the other one. Alright, so material LOD. Now what's the sampler? Good point. I might store this in RO sampler. We might make a sampler for, so it will be a repeat, I think. It'll be a repeat. Yeah, I don't really have it yet, so it's a repeat. So I think I got like the clamp linear or clamp linear or whatever, but I need like a repeat linear, I think. I think that's what we're gonna need to call it. Now we're finally passing the coordinates, so the layer needs to go in. So I guess we can just do this, right? Let's get it all into there. So this is the material preload sample basically. So this will be the coordinate, and that will be right. So we've got, okay, so this is where we're going to need to do the explain the octahedral thing. Hey Lupo, how's it going? Yeah, I'm doing bad. Just coming off of caffeine, coming off hard. Well, I managed to find some green tea in the cupboard, so it's been a little bit easier to come off caffeine. So I've had a lighter form of caffeine to help weave me off. But I woke up today like, So, yeah, African shirt's back. It's good. Yeah, you see with Vulkan. Yeah, well, the C API in Vulkan is much better than the C++ one. The C++ one is like, hey, do you want to include 100,000 lines of header file to basically do nothing? You know, it just interrupts with modern C++, which is not a benefit in any way. So it's a C API, and then they have a C++ API on top of that. Then I think some drivers are written in C++, but I think some are written in C. I'm not sure. I think so. I think maybe they've all definitely got both at the minute, but it's just which one has more of which, I guess is the question. Nah, C is optimal. Mm, so, uh, Zyber, do you want to learn Vulkan because, okay, let me gauge your. So, have you made like a 3D game? Or game prototypes. I'm not talking about like a 3D game that you've released or anything, because that's quite a lot of work. But have you made a bunch of 3D game prototypes yet? Basically, is the question. I'm the person. I'm the person to go to when it comes to giving up caffeine. Why am I giving up caffeine? Well, I'm just. It's just the sugar. No, no, sorry, not sugar. The what is it? I've just been having too much. Basically Pepsi. You know what I mean? Just I got to the point where I just slowly crept in, and I'm having like 3 cans a day. You know what I mean? And it's just I'm having too much of it. I do the same thing with sugar as well. Like I'll come off it, and then slowly it will just like creep. And I just have that sort of, you know, it's very easy for me just to sort of like get addicted to just doing a particular thing. So I just become aware of it eventually, and then realize that I'm kind of being a bit dependent on it, and then I sort of bring it back again. And it's that, I'm pretty good at it, to be honest. I can stay off stuff for a good while. It's just when it comes to like Christmas or something, it all just starts to creep back in because, you go to this place, you go to that place, and they've all got these things out there and all that. And you just start having, you know, having free reign and all that. Our experience with Unity is crap with OP. Yeah, yeah, yeah. One of how games work, right? So I'm trying to understand, Zyber, like, what is your level of experience? Because because here's the thing, Vulkan is a very insanely like complicated API. Like I understand it, and now for me it's easy, but learning it was like a right headache, and it was a headache because I didn't know how a GPU worked, and there were resources online, but it's difficult to find them. You have to read like all these PDF documents, and then like there's not really good like video resources on it. Well, okay, there is a good video resource. I can link to one, but I found this after the fact, obviously. So on Mali GPU training series. Top quality. Oh my days. Buy an ARM CPU for Christmas. Don't know what that was about, but anyway. It's not just for mobile, does desktop ones as well, and kind of tells you the difference in how they work and everything. But then also a good resource for learning about GPUs is reading the RDNA 2 ISA documents. They're a bit long, but you can skip to sections and just read all over the place like I typically do. Yeah, exactly. Exactly, Travis. It's not really a good easy thing to learn, is it? Like, and then eventually, like I think I threw away so many like test, like I was just trying to abstract over it, just figure out how the hell do I do this. And you know, now I can build one up really easy. It's just it's not really good API to learn. Like what you want to be able, what you want to be doing is, yeah. So Vulkan's easy to learn when you know what how a GPU works under the hood and what it is abstracting over. Then it's easy to learn. The reason why you learn Vulkan is because you want to have all the control and build your own API and use that. And you know about what it takes to build a 3D renderer and basically all the passes, right? You render your geometry, you render like, you know, how you do lighting, how you do post-processing, right? You know all those steps at kind of a high level, and also how the sort of textures flow, right? And what things you need to build underneath to achieve that, and you know underneath Vulkan how the GPU works. Then learning Vulkan makes sense and is good. So I recommend you, if you want to learn Vulkan, you first have made some kind of 3D render and understand like what it takes to build a 3D scene. So SDL3, good place to start these days. Especially if you're in indie, I think you can make a lot of good stuff with just using SDL. You know, SDL is a bit of a big thing, but it's definitely far smaller than any Unity project or anything like that. It's got a lot of stuff in it, but one of the things I recently added, which is really good, actually. I looked at the compared to I would prefer this over Web GPU, but SDL GPU. So you have to use SDL3. SDL GPU is basically an abstraction of Vulkan, DirectX, and Metal, I think. And you can use this to kind of get an idea of how you would build an API on top of Vulkan, but also use it to actually go ahead and learn about doing proper 3D development or whatever. And that this will help expand your knowledge in that. Raylib is pretty low level. Well, so you say low level as in like pretty amateur, not really low level as in low level hardware. Yeah, so Raylib is for like beginners. I would suggest Raylib's good for people who want to learn C programming and get into just trying to get used to C, but you can also put stuff on the screen really easy. Like that's what it's good for doing that. The API is basically like a toy API. It's not really anything you'd like to use in. You know, you can use it for like prototypes and stuff. It's good for that if you're used to the API and you don't mind it. But not for something that you want to probably ship with. SDL is the next one up, I would say. If you don't really want to build the whole engine, but you want to do kind of you want to build your own engine. SDL is that sweet spot where it's like it does all the platform API stuff, like to do with like interacting with Windows and Vulkan and all that now, which is great. As you get Windows set up and things. And especially if you've never done that stuff before, it's really easy just to use SDL, but I've gone through the hard work and done all of it now, so I kind of know what I want. So I don't really use SDL, but I have used it in the past, and I can recommend it. Mm-hmm. Oh yeah, another one is make a software renderer. That's another good idea. I've said that in the past as well. So so basically another good project to do, and I've mentioned this to Not So Red, who has not seen him for a while. It's probably not going to show up. Okay. So, oh no, wait. It was red one. Okay. Hang on a minute. All right, maybe not. I'm gonna send you links anyway. So another one I suggest to people as well, and thank you for reminding me, is basically write a triangle rasterizer. So this is another place where I wish I started. So I was learning OpenGL and I was like completely blind to what's going on. And there is documentation on places, especially like learn OpenGL and stuff, but to really grasp it is kind of long, and there's lots of stuff to understand. So a good place to get some sort of hands-on experience is making a triangle rasterizer from scratch. So there's one on Scratch Pixel here, but there's other ones as well. I think that this was a pretty reasonable one to do. Yeah, they said they teach you with like doing an array, but then also doing the do they do the slope thing? Do they do the slope marching thing where you sort of I don't know. But yeah, just you can Google a bunch of things to do with like software, you know, triangle rasterization basically, and just search that sort of thing, and try and render your own sort of triangles. You can build your own. Like I mentioned it to someone in the chat before, and they built basically their own type of. Yeah, and they wanted to learn Vulkan as well, so they made their own kind of Vulkan-like API, a very minimal one though, which kind of had like it had like vertex shaders and pixel shaders and pipeline stage stuff, right? And then they implemented it in software and even did like 3D lighting, and they had like imported models and did it all on CPU. Now what you can do is if you don't get the sort of window up and running, you can just output to a like a PNG file and view that. But if you just use SDL, SDL's got a way to sort of take a bunch of pixel data and put that on the screen. So you can do a bit of a software renderer as well, just to sort of learn how do these 3D API, what do these 3D APIs actually do for you under the hood. I think that's probably the best place to start. Is make your own sort of triangle rasterizer. Then how do you shade those triangles? And then that's the pixel shader, right? And then you put vertex shaders in. Then look at the sort of like Vulkan pipeline create info. So you create these pipeline objects, and it's basically a structure of a bunch of different state, and try and figure out how you could write that in software. But obviously not all of it, just parts of it. Like how do you do the sort of, you know, and just sort of see how they do that under the hood, and just try and implement it, and just get a feel for what these APIs are doing for you under the hood. It'd be cool. Well, if you really want to learn stuff, then use something like GLFW to get you window and screen. Do software and teach you the most. Yeah, something like GLFW or SDL. I like SDL more because it's like better controller stuff and you know, or like whereas GLFW is just a windowing thing. SDL is like does more. Right, so we get to explain the octahedral layout now. Octahedral mapping. So basically we're rendering a bunch of ellipsoids, right? So each ellipsoid gets its own material. So it's quite easy. And what people do these days when it comes to lighting and stuff is they basically have a probe, which is like a sphere, and they will map a normal direction, so an arrow on top of that sphere, and they map it onto a texture. So, you know, mapping stuff onto textures for like the standard way using a spherical coordinate, which is just a 2D coordinate going across the sort of longitude and latitude, whichever one that is, and it maps it to a 2D texture. But the problem with that is that you get lots of stretching around the top. Oh, what is it? The problem with just taking a 2D texture and doing the latitude and longitude remap is you end up getting around the top of the texture. It will sort of very quickly wrap around the whole top of it, and you get some really weird artifacts. I'm going to say sphere texture map. Yeah, there's a good one here. So I promise we can't really view this without clicking in here. Here we go. So see at the top here, it just really quickly wraps around there and it sort of distorts. So there's various ways you can go around it, and one of these ways is using the octahedral mapping. It does unfortunately have a bit of a distortion, but you know, the other way is a cube map, but a cube map has 6 faces, whereas this only has 1 face. So you can do what's known as a hemisphere, where it's half a sphere, or you can do the full sphere like this. So we've got a function which does this already for us. So that's an octahedron, and you're essentially making a sphere kind of map to an octahedron, and that maps to part of a texture. And we should even be able to do repeating as well, I think. But yeah. Yeah, it should do repeating as well. So we take a normal and turn that into a coordinate on this texture in this sort of layout. So I've already got functions for that. You can find these on the internet basically. So I just call it pack octahedral. So we take the surface normal, so shading. So we've got to take the surface normal in local space of the object. So that's world space. So I'm going to start suffixing these with world space, and I'm going to need a local space one as well. Now for crying out loud. Right, so what we're doing is passing this shading dot surface normal local space, and that will give us the texture coordinate. Now that would be 2D, and then we want to actually put the fill-on coordinate, which will be, so I guess that would be UV. Then I'll say coordinate is so because we've got a 2D texture area where all of the materials are packed into, or you know, streamed into basically different slots, uv.x, uv.y, and then it will be material dot. Well, it's the material layer index. And there we go. So that'll be the final one there, chord. So now it's just a case of, doing the rest of the that is declared, but it can't find it. That's okay. Just do the rest of these now. So it'll just be like for albedo. So that'd be emissive strength, which we'll find as well. So emissive strength might just be multiplied onto the emissive. Yeah, so we'll just say emissive multiply equal and then metalness and roughness are going to be their own thing. So I need to be able to get the MR, I'll call it for now, and that'll just be be mr.x. So metalness, roughness, and then we'll just do like that. That'd be good. And then roughness. Okay, so I think that's all the PBR bells and whistles there. That's all good. Oh yeah, so I don't have a multipliers equal. So I've got to do something like this. I might just copy paste that one. And then we'll just actually put this into a local called emissive strength. And then we'll probably say emissive multiplied yeah, that's just sampling a float there. Amazing. So I think that's all of those things filled in. So we just got to make sure that we obviously pass in a material index here. We've got to put in these globals. So I guess let's start CPU side to get all these globals filled in. Then we'll come back into the shader code, finish off this PBR shading function. And then we'll fix all the call sites for this. Should be cool. So we want to make that array filled with all the materials. We want to, well, we already have it. It's just we want to have it available to every shader without passing it in. Yeah, so read-only buffer of graphics material packed. It's really kind of like a material location, really. I should probably rename that. Let's call it materials. Then we wanted a sampler. So we've already got this sort of clamp linear sampler, but I think in the GPU abstraction we've got, I think we call it, I think we just make samplers with, right, so it's nearest and linear, right, yeah, the repeat, mirrored repeat, okay, so let's call it repeat. So we're going to have a repeat linear sampler, so I need to make that as well. So let's go to graphics side. What it is, we need to make a repeat. See, I wonder should I put it as part of the, yeah, let's make 2 new ones here inside the GPU layer. sampler filter nearest linear, right. And then repeat. That's it. Nice. Then I need those little functions that, right. Yeah, so realistically we should have nearest. I think that's it. Yeah. So we'll just swap that out for, rather than clamp, we'll do repeat. Nice. So we need to make sure they are in the header file. And I don't usually like functions like that, to be honest. So what we could do is get rid of them entirely and actually just make them publicly accessible via a structure, because we already have one of those now. It's called, it's here, right? So inside internal, I can just copy that, pop that in there, and then we have a globally accessible function, structure instead, so we don't have to make stupid one-liner functions. You know, much better. Nice. So back to graphics. We can then just say, right, GPU public dot that thing, done. So I want to do the same thing for nearest, or sorry, what was it called? Repeat. Okay, so there's one final one that we missed, and that was the materials. That is in the material cache. So I need to get the resource index. So it's in the material cache, and it is materials res ID, and voila. So that's the CPU side all sorted out. So let's go. So actually, though, you could have uploaded to it, and that explicit barrier that I put in, thinking about it, if the materials, if we have basically uploaded the materials again, we should put that sync code in. So let's do it here, right? So that'll be a GPU command sync read only. So we just do it earlier, so we don't have to keep doing it every single time we want to try and use it, right? So we palette. Oh, sorry, why did I say palette? Sorry, it's in the graphics. Wait. Cache materials. Yep. And then if the palette's changed, then it's palette. We'll just sync it once, and then all the future frames, it just won't bother doing any syncing until it gets uploaded again. That's in palettes res ID. Okay, good. Nice. CPU side code is now done. So the next thing to do is the sampler. Yeah, I think these things always have kind of errors, but that's okay. So let's finish inside this function. So now they're using sort of like, so rather than material dot, they need to be shading material dot. So I've just put in a structure so we can pass it around nice and easy. Although it's made the code a little bit wider. You know, it's questionable. So this is the calculated light radiance. This is called for every single light. So we've only got 2 hard-coded lights at the moment, and they're just yeah, I said they're hard-coded. I don't know why I said that twice, but there we go. So the metalness and roughness need to come into here as well. And that's that. So I think this is this one adjusted. So again, a quick recap of what we did. Oh, right. These need to be explicit now. They're surface normal world space. Because we got a local space one in. So that's all I think we changed. So the shading struct comes in, we added the surface normal local space. I've added this material into here as well. The material is just basically, I could probably call this like a sampled material. Something like that. Maybe. We'll see, we'll have a think about it. Let's just get it up and running first. So that just has the sampled albedo, emissive, roughness, and metalness that we use to the PBR shading. So that's just stored in this structure that we pass around inside this shading function. So that's all we already changed. And then it just does the PBR shading. Okay. Right, so now we've just got to change. So the other thing as well is it used to pass in that material structure into here. Now it's passing a material index. So every single time this function gets called, it needs to be using the right one. So we just got to look at all of these different ray tracers we've got. Right, this is that BVH one that we should probably delete. I don't know if it's really going to be useful, to be honest, to keep it around. I don't really like BVHs anymore. But I don't think they're ideal for GPU. I'm still yet to try an 8 wide one out. I think that might be better. But still, there's so many inactive lanes. Don't know if they're a good idea. So supersampled anti-aliasing. So when we get the render ellipsoid, we have the material index in there, right? Did we make it check the... Okay, yeah. Okay, so let's sort these out, but I think with that material index is not set properly. So yeah, these are emitted on the GPU in a previous stage. So we're just doing some ray tracing here against these guys. And we will just pass in, so rather than material, what we will pass in is e.material index, like that. So that's what I expect to be doing for all these other ones. This is the multi-sampled anti-aliasing rendering. It's done in software, so it's just a software implementation of MSAA. Then, so that's got the ellipsoid there as well. This one is the, is this the visibility buffer render? No, this is the ray traced anti-aliasing. It's just some one that I've made up. So again, we get rid of that steady hard-coded material, which I think I should have deleted that, but I never have. Just go to graphics, internal shared. Oh crap. Right, there's the global material. Let's get rid of that. This is the way. Okay, looking good. And next one. So this is the visibility buffer approach that I've done, because I wanted to see how much better it is or how much worse it is. Turns out it's better for smaller resolutions, 1080p and less, but anything above 1080p, the tile-based render is better. And my understanding of that is the fact that you produce a lot of overdraw by doing these atomic maxes into things. And it becomes much more costly. There's far more overdraw the higher the resolution there is. So I think that's what ends up happening. See the visibility buffer, I think we'll keep it, but I got to figure out when is the best time to use that versus using the tile binner maybe. It might be an optimization for lower resolutions, maybe. We'll see. But then the problem is I have to make 2 different renderers. So, which is not that bad actually. It's just there's more surface for area for bugs. I guess that's the biggest issue with it. But it's cool, it's interesting. And then I really want to try and do that visibility buffer AA thing I've been trying to fudge. I've got a chance to come back to that. I'll do that in the future when I want to bother trying it. It's just some custom anti-aliasing thing I've just been screwing around with. It's not anything that's searchable on the internet or anything, it's just me being curious. So effectively I'm able to get all of the edge information from the visibility buffer because it's just you emit an ellipsoid index and a depth. So with that information you can get the perfect edge information. And then I'm trying to sort of like probably do something very similar to FXAA basically, where I, blur the edges. So it's kind of like my own version of FXAA, but with a visibility buffer. That's what I've been trying to get working. Oh, I have it working. It's just it doesn't look good when you move. So I know what to do, but try and fix it. But yeah, that's where that's at the moment. So hopefully that should be the PBR thing sorted out. The next thing then is when we emit those render ellipsoids. So this is called. So we go over all the models, and then we go over all the ellipsoids within the model. I was thinking we should probably separate these into 2 different passes, but I haven't bothered doing it yet. So, but right now it's fast enough. It's really negligible. It barely costs anything to do this, so I don't bother. I think right now because we use the same model or something. I don't know. We'll see what happens when we introduce tons of different models. But so in here we emit this render ellipsoid. Now this. Right, so source material index, where's that coming from? Is that coming from the actual... So source is the packed... Right, that ain't gonna work, is it? Okay. So the way I decided to do it is every model has a palette. So you have probably at most 16 materials, right? 16 ought to be good enough. And then you just can remap that. I think it'll be in the shader. We're going to map that local material index into a material palette that is currently used for that model instance. And then you'll get your proper material index, which is 0 to 1023, right? And that is what will get passed into here. So I think what we're doing CPU side is I think it's called find or load model. So we just find or load a model, right? Hardcoded material index 0. So this needs to be the material palette material index, basically. There's probably a way I can shorten that name, but yeah. So model render ellipsoid packs. This will be. So when we pack this down, it really only needs to be like, yeah, fit into there. So that's not even really packed, but I want to have fun packing this. But there you go. We'll pack the alpha into 8 bits. Why is the alpha per... Oh, it would be. And then you could probably have an alpha per model instance as well, if you wanted to. Let's have a bit of fun. Let's do a bit of packing. So let's say we only really need 4 bits for that. And then we only need 8 bits for that. It's interesting. And then we want to be able to pack a transform down as well. I was thinking we could pack it down like that. But now... Let's change that. So we've got some sort of unused. So 12, so there's 20, isn't there? I don't know what we use that for. Let's just leave it there. Yes, that's a material palette, or okay, a palette material index. That's the better name. That'd be ideal. So we'll regenerate that, so it's just running the code gen scripts. Oh yeah, it needs a min. Oh, I thought you didn't need to define a min-max value. Oh no, you don't for range types, but you do for packed types. Yeah. So that'd be 0 to 15. Whereas this one will be 0.f to 1.f. Maybe you don't need to do it. Wait, you shouldn't have to do it for ints. Oh yeah, sorry, you don't have to do it for ints, but you have to do it for floats. Alright, that's better, so let's rerun that. Cool, so it's all code gen there. So now what we have to do is go to the CPU side code where we set this. So now these are set using those generated macros, so it's just pretty easy to work out what that is. Packed set alpha 1, so that'd be dref then. And then set material index. Sorry, palette. Now I think we did some sort of hard-coded bits and bobs here as well. Let's just comment all those out. Okay. Now, right, so GPU side in the shader code, when we emit those ellipsoids now, only that source alpha. So source dot alpha. Yeah, so we're reading, so we've got a model instance. Wait, does that model instance have a material palette? There's a palette index. Amazing. Have I even got any palettes uploaded yet? Don't know if I have got any palettes uploaded yet. So it was in the graphics internal. Material cache, we're looking for like a... Oh no, we would have. Wait. Oh yeah, we've hard-coded in the material cache update. We've hard-coded like one to be loaded. Right, and that gets uploaded, yes. And it's just we haven't got it in the globals to make it accessible to every shader. Yeah, the problem with this approach of doing these resource indices is they're in... You go into one buffer with to get more buffer indices. And there's a couple of layers of indirection here, rather than passing them up through the push constants. So I'm hoping there's we maybe compile these down to some static indices, and then we don't have to fetch them from a buffer, and that'll be the next best way of doing it. But until then, we shall just do it this way until I have to do optimizations. So material palettes, so graphics, there's a materials Okay, so now we've set that buffer there, so it's globally accessible. We've already synchronized on it when it got uploaded, or after it got uploaded to, so we're already synced for it. So it's read-only accessible now. So, yeah. Now all we need to do is go to the shader code. And then here, so we go for every model instance basically, and then for every ellipsoid within that model, we pull out the packed ellipsoid, which is in the space of the model, and then we move it from model space into view space basically with this sort of view from ellipsoid transform. And then, you know, we do all the sort of like bounds checks and checks if it's, sorry, we check if it's still on the screen basically behind the camera or yeah, kind of on the screen. I need to do proper thrust and culling still. So I haven't got around to doing that. Then I got to check against the occlusion buffer, and then we produce what's known as a render ellipsoid. This has the ellipsoid from world transform, which is what we use in the ray tracers mostly. Well, we use both matrices. We need to pack this down as well. And then the full-on material index. Now we don't have material index anymore. We need to get that. So let's be careful. Where's source.alpha? So it's here, yeah. So to get the source alpha, we need to extract it using graphics model ellipsoid packed alpha, and that reads it from the source structure. Then we need to read the full-on material index. Well, I need to get the palette, isn't it? So it's a graphics material palette packed, and we'll say here's the palette. So that'd be graphics global, and we'll access that buffer. So the buffer is the material palettes, and we're going to fetch it with the graphics model ellipsoid. So it unpacks 4 bits basically that we defined earlier. So that was the palette material index. So we get a value from 0 to 15 and pull that out. Wait a minute. We need to pass in the source. There you go. So it unpacks. So inside here, right, we've got that sort of bit field. Well, it's not showing it because I need to go to the graphics shared generated. So this is the code generated file for it. It's got bit filled there now, and we've got these little macros that just extract out the bit filled, the alpha, and the material index. So that's the 0 to 15. Sorry, I jumped too far. Sorry, it's me been done. That's in palette materials, material indices. And again, later on we might pack this one down a bit, but we haven't. So it's just an array of 32-bit integers, but you're right, it's just an array of 32-bit integers, but they only need to be 10 bits each. So maybe we'll pack those down. We'll see. So to get palette, you get that from the model instance. So the beautiful thing is about it is that you just need for every one model, when the model passes the occlusion test, you just put this here like that, and then you go okay. So it'd be model instance dot palette index. So I think from the CPU side, when we do model instances, we get the palette ID and we get the bits from, or the index bits from it, and throw that up there. Job's a good one. Right, very good. Happy with that. So that gets you the material index, and boom, there goes the proper material index into the render ellipsoid. So I think we're ready to roll. Let's sync, build, and go. Right, so we're sampling a... Okay, so the albedo doesn't need the alpha channel, basically. Yeah. Yeah, but we do want to use a BC texture eventually and only use that BC1 or something as well. See, I think we should maybe limit it to doing a... Okay. So albedo and emissive should only be 3 vector 3s. So then inside calculate surface color, we can get it to do that and it won't complain anymore. Cool, so this one, it used to pass a material in here by value. You know, to be honest, why have I stuck it in? You know, yeah, I'm starting to change my mind on it just a little bit. Okay, I think the language server protocol died. LSP restart. Okay. So I'm not putting it in there actually, it's a dumb idea. So we should probably call this the material location. Like it's an LOD and a layer, but it's not the actual material. It's one of them, isn't it? Or maybe it is the material. It's a material location, but then like, and then what you're producing is really probably a sort of a sampled material, maybe. So rather than putting in this sort of shading dot material, we'll just put it in this material strut and pass that around. That would be better, wouldn't it? Restore it back to what it was, basically. Ooh, that should be e.material index. Much better. Let's give that a go. So surface okay, so all those surface positions, and we never filled in the surface normal, local space, or world spaces either. Right, is that the BVH ray tracing shader that I should just not be maintaining anymore? I don't know why this is not commented out, not gonna lie. Get out of here with that one. Right. Let's keep going. So, right, so all of these, that's a world space now, so I should probably really look for all of those. So it's a world space. Then this is a world space one here, but we also want to store the lovely local space one because we use that to sample the textures with. So again, world space, copy paste, local space, hit normal. Oh crap. What shade is this one? Is this the... This is the RT. I need another erase. It's going to make the shader slower, but there you go. I was thinking of getting rid of this ray trace anti-aliasing and making it do no AA, in the ray tracer, because the problem is we do it based on near misses, and then you get a bunch of like inactive lanes basically. So I'm thinking of maybe doing like a post AA for this one, like my own, or that the probably my own version of FXAA maybe on top, because I can get perfect edge detection, and that it might be good enough. And then we don't, yeah. So this can be. I'm gonna make it less optimized now, but it's more VGPRs. But there you go. Goodbye VGPRs. No. But anyway. Okay, so I think I got that there. You hit normal local space. Good, good, good. So that'd be hit normal LS. Okay. Looking alright. So, right, this one's the visibility buffer shade. So it's the post shading pass. So world space, and again, finally local space. So I think that's those. Right, so what's this one complaining about? So 67 E. Right, there's no E dot. Material index. So in the hit list, you put the, right, there's the E there. Yeah. But you already read the, right, again, let's just waste more VGPRs. One, I could instead cram the material index in the low bits. Right, it's called the M index now. So I think we can instead cram this not being used anymore. E dot material index, and then we can say down here when we read it out. So it'd be and RTAA material index mask, and then we'll just pass that into that function there, right? So it's not made it that bad. And here we go. I've gone and found a compiler bug. So what's going on? Expected data type to be a resource type, but got 8193. Beautiful. It was 8193. Joys. So in terms of like stuff that's been doing resources, we've done a lot of these like bindless indices. We've put them inside buffers and stuff. Hey Dora, how's it going? Welcome, sir. It's been a while. How have you been? Damn it, bitten by a shader bug. Sorry, shader compiler bug. So where would this be? So if we go into internal shared. So we do some bits and bobs here. We can start commenting out the code really. You know, the easiest one to comment out would probably be the shading one. So we did these sorts of things here, right? So if I was just to comment this out, does it compile? It really is doing fine. Woke up really early and so kind of caught the stream. Awesome. Yeah. Okay, so we found where the bug lies, or what is causing the compiler to crash. It's one of these functions, probably. Probably any of them will do it. So return type. So it's return argument. If I was to do this right. Sampler texture 2D array. Watch it work. Hang on a minute. Sample texture. Oh. What's this complaining about? Implicit MIP. Oh, he's explicit MIP, isn't it? Crap. Yeah, but anyway, we're getting past that bug. So let me just put an explicit MIP in. Sample MIP level. How do you do that these days? Just, you do that 0 like that, isn't it? Yeah, there you go, works. So return type parameters don't work in my compiler for some. So I was to. So I've got to put it into a local. So yeah, so at least we know what the problem is. So I guess it will be easy to fix. So generate descriptor load. So generate instructions at question mark, great. But 293 is one. Yeah, it might be quite easy to find. Binary operator, right, then it'll be a right hand side, then it'll go into a function. And then your resolve function, you'll do a call. So the call is gonna, right, it has a return operand. And then yeah, that should work. So there's a return operand and then it goes into so that's the return operand. Yeah, it returns that out, right? So then you'll do a descriptor load on that, I think. Right, where's the descriptor load happen? So a descriptor load takes an index and gets you a resource from the bindless arrays, basically. So it was an array subscript is part of one of the intrinsic functions, right? What is that doing? Why is it doing that here? Oh, these do breaks, right? That's for the printf string thing. Sample texture, one of these guys, right? So it's temp operands. Right, where are these temp operands getting filled? Right, so the call arguments. Okay. So like if we were to say right, so when we go into these sort of okay, then it gives you a number 83. Right, so if I was to pass in 83, I would know what it is. Sorry, 8193. What is an 8193? So in hex form it's oh shoot, what did it do? Yeah, so it's got these bits on. It's got the first bit on and then the 13th bit on. So if we take that should be a resource. Oh crap. Should be the resource type. What's the new code for? Oh, we're currently working on materials. So we're trying to load them from textures now. And then after we can load them from textures, we can then build an editor which allows us to procedurally generate materials for ellipsoids and stuff, like in the editor, but also, so you'll be able to view them in the editor, and then you'll be able to write shader code and sort of tweak it live, and then like, yeah, tweak the shader code live, and also view the results on the ellipsoid that you're sort of trying to build, and then the texture for it, and then you can use that throughout the game basically. So we're going to be building some sort of procedural texture you know, system. So I guess the easiest way to describe it, are you familiar with like Substance Designer or whatever you call it? So imagine Substance Designer but without the node programming. So you basically will just have a way of not having a whole UI for node programming. We won't be doing any of this, but we'll be you just have a shader which runs, and then it generates the material, and there'll be viewers, so you can view the sphere or ellipsoid right when we stretch it, and then see obviously what the texture looks like as well, and view it at the different stages of the procedural texture creation, and then we'll be able to make stuff. I don't know if we're going to be doing. We'll be able to make stuff that maybe looks like this in a way, but I don't really want to do like probably realistic stuff. But yeah, we won't be doing parallax occlusion mapping though, because I don't want to be doing that in the shader. It's too costly to be doing parallax occlusion mapping, and we're not really going to benefit from it, I think, anyway. But yeah, so we're kind of build our own sort of like little mini substance designer thing basically after we get the material textures working, and that can sort of pack it down into these textures. We can edit into these assets, and we can edit it all in an engine, which would be proper cool. So be really powerful. So we won't be like hard code painting any textures or anything. So if we look at the resource type, somewhere in here, is right, but we've got a 1. So the data type, how's it packed again? So the type is in the first bit. So if we got a 1, that's an intrinsic. Did it really pack it as an int? Does it think it's an int or something? Does it cast it into an int 32? That'd be interesting. Let's see that. Can I view the I'm gonna build third party. I've not done it on this one yet, have I? Hang on a minute. I can debug print the abstract machine language. So I want to do that with -- debug AML gen, I think it is called. Oh no, I want to debug the AST maybe. Beautiful. That's what I want. AST. Right, let's have a look in here. What I could do here. Right, so we're looking for that shader, calculate surface color. So we do, it's got to find the octahedral. Where's the line? It's this line here, isn't it? Oh, that's right, this is the tokenizer. Whoops. Right, yeah. So let's find it when we, not in the tokenizer. Yeah, this is the abstract, sorry, this is the abstract syntax tree. Yeah. So, right. So in here, we've got to find when we call that function. We'll see if there's any crazy things going on with like casting or anything. So, right, forward decal, what's going on here? What's this thing saying? Oh, okay, that's just saying it's sampling. Right, here's this guy. Function type 40. Expression call. But what are you returning? It's not returning. It's not telling me what it's returning here. It usually, we usually put this sort of casting thing on here, right? It's not telling me its return type, or is it? Why have we got a graphics material written there? Graphics material pack. Seems a little bit bananas to me. Yeah, I'm a little bit confused on. So another thing to do would be like, if we go to that, we can see what's going on, right? If we, so if you put a function call within a function, is that just not, no, that obviously works, right? Because we have something like this. So we look at this reflect here. Where's the reflect? Yeah, reflect and negate. So they've got this sort of like function type thing here, right? But we're not seeing the. Oh, it just says 32, right? F32. Why does it say that? See, I think this is a little bit busted. Because that's obviously a vector. Yeah, I think it's to do this forward decal thing. I think it's a little bit busted. But so we should be seeing this printed out here, but we're not seeing. Right, let's go to that AST sort of debug thing. So it's basically somewhere here, right? Compound types, ain't it? Functions, right? So you go round. Yeah, print expression. Expression. That's a call. And a call within a call. Right, so I think we think it's a statement, right? Yeah, so it's not printing out this because it probably thinks it's a statement. So with a function, so for the call, how do you know if it's on the expression, right? Interesting. So we're gonna do a call. Right, so expression, call, left, right. And then, right, it prints. The right expression. Yeah, I don't think they're being marked as expressions. Oh, next statement. Oh. Next. Right, okay. Weird. Okay. So these are not being marked. Well, let's fix that then. And that can help us with the debugging experience. So when we go into the AST gen, so when we produce that sort of expression call, call expression. Oh, they're marked as statements then. Damn it, why are they marked as statements? So you see next statement, but then how do you generate the... Right, so maybe they're marked as they're statements. But why would you do that? So you have this linked list of call args. And how do I usually get those return types in the next stage then? So just go to the abstract machine language generation. When you get that sort of call, right, how are we generating the args? Well, callee, right, so that you get it from the function type. So you go over all the args. Wait, where's that? Here. Here we go. Generate instruction, what's that? One variable ref, expression. Right, and that's going to use the data type in there, isn't it? So like, say if you've got like a... Yeah, I don't know what's doing then. So yeah, so say if you end up doing another... I wonder if we use the data type in this anywhere. So curly brace initializer, we use that data type there, obviously. A cast, we use the data type. So if I put a cast in as a parameter, it's gonna lose Gonna lose that, isn't it? That's gonna get lost because it's a statement, and we will overwrite it with the next pointer or something like that. Yeah, I think this is what's going on. Like, we're losing the data type. So in that case, so it's a function call within another function call. That function call will generate some instruction. Call the expression. Callee is the sort of the function name, basically. And you're trying to get the return type for that, so you know what the return type is in that way. But then each argument... Okay, so maybe it's okay. Oh, it is what happened there. Yeah, so at the end you are returning the return operand. So where the return value goes into. This is all intrinsic functions getting remapped into something else. This is just a regular function, which is what we're dealing with. The return data type comes from the callee, so that the function name basically. So that's okay. So the arguments that get... Yeah. That's right, isn't it? That's worked out okay, so... Well, obviously hasn't, right? So... Hmm. So left hand side get the callee, right? Yeah, so the value got back is 18193. And by looking in the header file, that's a 1, which is an intrinsic. And then it's the 13th bit, sorry, 14th bit on. So how many bits have we got? So we shift right by 10. 8. So for an AML intrinsic, what is 8? Is that an integer? Is that an int 32? Yeah, it's an int 32. So did it get casted into a... So it's not a resource descriptor anymore, it's an int 32. Sorry, it's not a resource type, it's an int 32. So int 32 is cast into a resource type in this compiler. So I wonder... I wonder what happened. So why would this return? It returns this sample texture, and then that gets turned into an int somehow, but it doesn't say it here. So that means we call the function. And it's saying that the function's return type is a U32. Oh, I know why. It's probably reusing. No. Right, let's look at that. So when we make a function call, the return data type on the return data type, where's that gone? Right, so you get the return data type. Yeah. Seems alright to me. Nothing sort of special going on there. Right, let's take a quick break. Be right back. Hey, welcome back everyone. Right, so we're going to build a very small test that tests this out and we can debug it a lot easier. So we go to, right, so we're going to make a new file. We'll call it well, let's go into here. So we're going to have a cd into build, right? And we're going to make a new file called like test, right? .c. So it's just going to do a very simple. It's going to include lib HCC intrinsics HCC shader, and we're just going to, you know, sample texture 2D. So the bug basically is like, hey, returning a texture of some kind. So let's just cast an int into the texture. And then what happens is I'm using a compute shader or something, and I basically, so, ooh, what is it again? Right, this will do it. So I basically just cool. So the problem is when you use a texture, isn't it? So maybe you know what we say. Yeah, say color equal sample mip level texture 2D. One of them at the moment. Then right, so it'd be text. That's the thing that make it fail. Now, so maybe we could say fetch texture, and that would require less parameters. Then we're trying to fetch a texel of coord, let's say. Done. That should do it. So we make a little build thing for that. So it's HCC. I forget my compiler. What is it? So it's file input, which will be the test.c, file output, which would be test.spv. Whoops. All right. So we need to include the libc standard int as well, and the vector maths. Yeah, that was on a cast. That's why. Cool. Right, so I can't cast a signed in, but I can cast an unsigned in. Okay. Fetch texture needs a mip level as well. Alright. Here we go. So what we can now do is we can run build, and then we can run, you can do debug builds basically, and then run with ./build hcc fi test.c, then a fo test.spv, and then, oh crap. That'll be it. To test and debug what's going on. So what are we trying to do? We're trying to find out basically if we've got a function with the name. No, we don't have to retry much, is it? Well, that's not a very minimal test. The minimal test would be this. That would be the minimal test. So we know we've only got one function call in the whole program. Sorry, we've got two function calls in the whole program. So we can get the return types of both of those and see what they are. So if we say here, we can get the string. So we can say, let's call it S. That'll be HCC string table get. So then you can say something like HCC data type string, I think. Oh no, it already gets you it. Okay. Right, passing the compute unit, and the return data type. And now here we can just basically print out to the terminal. Call it s.size, s.data, and voila. So we try and see what that prints out. Right, of course we have more than one function. So what we're trying to say is if this is not a... If we're not... Yeah, this is where we've got to be careful. We need to make sure that we're calling from maybe a C file or something like that. Well, it's okay. We're seeing it here right at the end. It's processed at last anyway, so I guess... Right, this is the last two. So that is correct. Because after you sample, then that's the sample texture. Good. So let's take these two on a journey into the abstract machine language. So in here, when we do a function call, what is the return type? Oh, it lowers it to the abstract. Oh. Right, that could be the bug there. It lowers it. Yeah, let's print out the return type here. Wait, why aren't I seeing it a second time around? Why am I not seeing it a second time? So the first time it's going to come around and you're in the call instruction, so it would have already... So does that text... So it does the first one, and then it goes to do the second one, and then that... But it does the second one in this call here, which case will come around again. Then it should hit here. I don't understand why it wouldn't be hitting here. Right, so 645. Fetch texture. Right, so as if it's not calling the next function for some reason, sort, you know, it seems like what it's doing. So we need to then say, right, if it's equal to, we can put a breakpoint in or something like that. Have a look at it that way. But yeah, it should, so somewhere in here. Okay, so we're looking to see if it's one of these guys basically is an intrinsic call. No. We're looking for that. We're looking for... Is that the only type we've got? Oh no, there's not. Yeah, I wonder how many calls we've got to sample texture. I don't think we've got any. Yes, I think we might be able to get away with... You get the decal index. So you go... If this is true here, well, you won't know that until... Right, let's do a bit of reshuffling for a sec. So if we put this here, we can then say if... So on the else one, And we're trying to say if this so it was fetch texture, wasn't it? Yes. Oh wait, how do we get that? Right, so it'll be right, if many equal texture. Fetch texture, we can use Clang's debug trap, but that is built in, isn't it? Built in debug trap, that'll do it. So let's try that. It should hit the trap. Good. So now we simply just gf into that. gf-args. I didn't get why I didn't do it. There we go. Right, so now let's go around and see what's going on. So there's a binary op, which is then another call. Interesting. Yeah, then it should print it out. It's a U32 at this point. Yeah, why doesn't it print this out? Have it got the new? It should flush. Right, then it would go to there, then return. And then it would carry on then. And then crash, basically. Oh, right, okay. So the print was the wrong way around. Okay, so we're in a good place. So I wonder if I want to keep the debugger going, to be honest. So yeah, so it is getting a U32 back. Call the expression data type. Is it one of those? It's a statement, isn't it? That's why, for some reason, I've marked it as a silly statement. So and then yes, the call the expression is the left-hand side. And then because that's part of a yeah, but it's the left-hand side, so that should be yeah, we'll look into that again. Let's go around again. So first argument is a function call. And then what's the return data type? That should be a function, right? Yes. And the data type it got was a U32. So when I encoded it... Huh. Right, so then when we generate the AST, when we make a function type for this, where's that? Oh, so the callee is the function expression is here. So when you make a right, so maybe when you make a function type. Yes, it might be that. Right, let's undo all that. Okay, so it's when you probably make a function then. So the function type that it makes at the end of the Right, so there's some kind of function type somewhere. Let's find it. Nope. Function data type. It must be in here. So you'll get all of your parameters and oh no, so it's when you make a call, it might be in the right, it's when you reference it, isn't it? Resolve. Yeah, it's when you find a declaration. Just got to figure out what it is. Like when you resolve an identifier, isn't it? Something like that. So you do a lookup. Got to find where that code is. Oh, here's an ident. This looks familiar. If you find a variable if that's not there, then you look in the hash table. If it's a function, you can get the function data type for a decal. Okay. Right, but function get function data type. Where do I set that? Right, this is what I was looking for. This line right here. Data type deduplicate. So maybe what we do. Oh, for crying out loud, look at that. That's a problem, isn't it? Why did I do that? So if it's a resource return type, turn it into U32. But not for hashing, right? Yeah, so it does it for the hashing, but sorry, not for when we store the final parameter, right? Yeah, so it was because in Spear V, this is the reason why I did it. Because in Spear V, right, oh my days. If you have any of these as function parameters, they've got to get the same data type. But then in Spear V, sorry, okay. In Spear V, if you have a function type which has the same parameters, the same type parameters, you can only have one of those declared in the whole file. So this is a case of deduplicating it. But don't I have a separate deduplicator in the SpearV code? Thought I did. Or maybe it's just a remap. Ideally, we should have a separate one in Spear. Like this code here should not have to do that. So it deduplicates the type. Yeah, really, we should have another hash table in here, which checks to see if the function's already been declared, and then use that one instead. Basically. So we should go back to here, get rid of these silly lines. Then in there's another one up here. Then in SpearV here, where we do this, is this a deduplicate? Yeah. So I've done it in the past. I've already got some kind of like hash table, I think. Type table, yeah. Hey, Tin Spin. Not doing bad, thank you. Yeah, doing alright. Just did it with a compiler bug, you know. Um, was working on the material, trying to load materials from textures, and bumped into a bit of a compiler bug, so I'm just dealing with that right now. First one I've had in a while, to be honest. But yeah, we're just trying to do some sampling of materials. So changing the render out for, rather than having a single material for the whole ellipsoid, we're going to actually get it from textures now. And in the future, we're going to be procedurally creating these textures through code, like just through shader code, and then saving those out to disk and loading those back in, basically. So we're working on that whole sort of system. This is what we've been working on. But yeah, how's things with you, Tinspin? So we've already got a hash table for the type. So what we would like to do is probably make another table. We could probably call it function. It's good. Switch to 2D MMO. Almost done. Got only the second 90% left. Awesome. That's cool. It's amazing. Yeah, 2D is far more simple. Get a lot more done. So if I go over all the operands, so if I spin over all these, grab the SPIV types, hash, 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 then check the hash table, and then use that result if it's there. I swear I've done this in the past. Oh yeah, we've done it with this thing though, innit? Yeah. Right. So maybe we should say, hey, if it's a function type. Yeah. Excuse me. Yeah, so I think maybe instead of making a new hash table, we could find hmm. Oh. Yeah. Hmm. I wonder. So it's going over all of those parameters, parameter data types. And we used to change out for a E32 if it was a resource, right? I'm just going to do this in the SPIV code. Right. We'll make another hash table. So if you get a oh, interesting. If you get a resource descriptor, does it turn into a U32? No, a resource. Yeah, it turns into a U32. Amazing. So when we do a deduplicate, so we'll call the same function again, for every function type. Yeah. Alright. We'll just add another hash table. So right, types or constant. Right. So we could just hash all the... Yeah, we'll do another one of these. Function type entry. We'll just store a U64 hash. Will be good enough, I think. Hash all the parameters. And you get back a SPIV ID. Something silly like that. So function type table. I think what we can do is, gotta be really careful though. So that's gonna fit in all those operands, and then actually push another type on. Or maybe it could be a layer on top of this where we can deduplicate. So you take all the operands. Maybe they can get rid of the hack as well. So the hack is... Yeah, maybe you can get rid of this hack as well. Yeah, so you spin over all the operands. You compute some kind of hash, look up in the hash table, and then use that to find yourself a type or constant. Yeah, find yourself a type you've already added in. Got it. So if you do that, okay, right, I know what to do now. So it's not really a function. So I've already got this type table that maps a the key being a storage class. Right, so we want to have a call it the unique type table. So we can just call it hash or something like that. That'll do. Alright, so what we're going to do is find or insert. So you got all the operands at the ready. We don't need to allocate a new SPIV ID yet. First we'll do a find or insert into this sort of unique using some form of key. So the key in our case is this hash. So we'll compute the hash. Have I got some like FFV hash in here or something like that? Don't know if I got that. Got it. So we're just going to go ahead and keep hashing all of the operands. So it'll be a lovely for loop. I've got one of these. Probably not. Operands count. And we're just going to go over all the operands for this type declaration. So the spear v operands. So it'll be address of operand. Size of U32. And the value, so that'd be hash. So, operands hash. Alright. So you do this sort of like find the index into the table. Now you get yourself this sort of entry thing. And then you say if it's new. You do all the code that we did before. Insert this into the table. Else, we've got an old entry. So we need to make sure that we store that result into the hash table. And then if not, we need to load it. That. Then if not, we need to load it, right? So that'll be a... Right, so anything left to do is to actually initialize the code. Sorry, initialize the new hash table that we made, right? So that'll be in spearv.c, I think. We made a type table at some point. Let's just use the exact same. Right, we're going to need to use something a little bit different, I think. So the key compare. Let's look at that. Right, U64 key compare, we've already got one of them, nice. U64 key hash. Cool. Right, that looks good. So let's give that a launch now to see if we've fixed our problem. Oh, nice. So let's see if let's go to the samples and run the samples application. Right. Apparently it all still works. So I wanted to fix that other bug I had. Well, not the other bug. the extra bit of code. So we've now put this deduplication layer in, so that the SPIR-V type definitions are all deduplicated now, right? So I guess let's put a comment here, right? Make sure the SPIR-V data types are unique, are deduplicated. Look up into another hash table to make sure the SPIR-V types themselves are deduplicated. Right, so it's just a little silly little hash table. Should hopefully do the job. So we should now be able to get rid of this code. This was a hack because SPIR-V, the op image types that are being generated ended up being the same for different resource descriptor types that we were making, but I think we can just do that and it should just work. So if we go back, regenerate, and test out that little example. Right, this one's still failing, but it shouldn't do because this new thing. Duplicate non-aggregate type definitions not allowed. But we've got a thing in here. Which says if all of those are the same, then if all the operands are the same, then oh, I don't know. But hang on a minute, I just thought we should hash the count as well. The operands count must be hashed because then it means that you get less collisions basically with the same number of operands, which is what we're looking for. Okay, that's good. Right, so I wonder why it didn't deduplicate the so the image got made, right, and it went and did this. Code, and if we see it's an image of float 2D. Oh, I passed in the damn key in here. Crap. Operands hash. Right, that's a good catch. And we'll do another test as well. Right, let's get rid of that and try it again. Is a void type? What? Alright, okay, let's go back. So, void type. What size is the key? Size of deref of key, right. Yeah, we passed that in. Right, so it's able to figure that out. Interesting. Ooh. Right, it's looking okay. So I wonder what would be... Right, so this next one is a op type array is void. Right, so that's clearly the... Trying to declare the resource descriptors, I think. Array of 1024 of them, that looks familiar. So the resource descriptors, when they've probably been looked up twice, is probably the fact that we didn't store it, yeah, in that new type table we made. I know the problem. We didn't store it in there properly, so when it's new... Oh no, we did. There. Oh no, there's a return here, look at that, sneaky sneaky. There's our problem. So, what's this saying? Oh my days. Right, okay. Oh my days, what a bugger. So we should just say spear VID. Is equal to runtime type ID. That'll do it. What the crap? Why is it still failing? Right, so it's a resource descriptor that comes in. If it's a buffer... Right, the operands got changed. No, 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 no. No, they didn't. We're just doing more different things, right? So these are just emitting new things like decorates and member decorates onto that. There's an array of resource descriptor of something. Hmm. Where is it? Where's the problem, eh? So it must be in this code here. Because that's what I think these are, the resource descriptors, an array of them. So it's saying it's a void type? Hmm. So an array of void. Right, so that's op array. So when we're doing this runtime array, there's some returns here. Sneaky, sneaky. Right, I found the problem. Right, some more earlier returns. So Boolean is also a bit of a culprit as well. Like, yeah, it just gets you back in it, doesn't it? So why don't you just... See, at this point, you already would have tried... Yeah, so the Boolean's fine. Because it's going to put it in that entry one. It's not looked up into the other hash table yet. This resource one should be fine as well. Yeah, so we've just gone into this hash table here. It's going to set that. It's okay. Yeah, I think that's alright. So where's these... So this is like an op type array. So what an array here. Where else are we doing these? You know, there is the runtime array that we've been using. But that in Spear V land. Yeah, they would say op type runtime array. So that's not it then. What's 1024 of what? Right. I think I might save this one just for off stream and finish it up off stream because it's probably just a weird little bug. It's not worth solving today. Right, so I guess let's just round this one up. So hopefully this will work next stream. We'll get these compiler bugs all sorted out. And so next stream, what we're doing, material plan. So we've hopefully got this done today. Turn array hit into a UV. We need to calculate the MIP level. We are sampling the textures. So we'll try and calculate the MIP level properly. And then we want to try and do the code which will read back the level of detail from a compute. So the compute shader will emit a bunch of LODs that materials have been sampled at and send that back to the CPU. And then we need to respond to that code. So hopefully next stream we get these things done. So calculate MIP and that sort of material LOD calculation code that sends back to the CPU, and then the CPU can try and load more higher levels of detail and stuff like that. Right. Okay. Let's see if there's someone to raid for the time being. So yeah, Thursday, about 4 hours ago, we'll be streaming on Thursday. Sorry, about 3 hours ago. Yeah, I'll be streaming on Thursday. Same time. Right. It's very valid ago. Alright guys. Hope you have a good evening and a good Wednesday. I'll see you all in the future one. Right, catch you later guys. Bye bye.